talk about Hindenburg model. Last time we talked about vector range. So before we use Hindenburg model, usually we need to use vector configuration. So it's similar to LLM, large language model, or region language model. That's meaning we need to, before, for example, I'm doing facial expression, especially I'm probably one of first one do the facial expression recognition using Hindenburg model。就大概全世界，我现在大概前面几个人用 HNN 在做人脸表情辨识 ，because about that time is about year 1993. People use Hindenburg model for speech recognition. I'm one of several probably. There's few people we feel because the speech is temporal domain. I do the facial expression. So what kind of model can I model facial expression sequence? So at that time, my advisor give me this project. Also, it's my thesis project. So I'm thinking, because before, when people do the facial expression, they only use one image. So one image is fine. But regularly, if we use sequence, the recognition rate will be better. Like you do the action, the skeleton, you do the action, you do the motion. And motion is a temporal domain. Temporal is a time sequence. And how can you recognize the sequence image? So I'm thinking about that one. So at that time, I have two choices. One is using neural network. So at that time, there's a neural network for time delay neural network for temporal domain, but that's not powerful. It's not easy to use. So I'm thinking is because speech recognition, speech is 1D plus time, so 1 plus 1. They can use Hindenburg model. And image is 2D plus time. So I'm thinking I can use Hindenburg model for this process. So I start to learn Hindenburg model. So Markov model has two kinds of Markov model. One is continuum, the other is discrete. Continuous signal, the other is discrete. And continuum Markov model, what they do is that each time they use a Gaussian model to model that situation, that image. So each time it's one Gaussian, next time it's the other Gaussian, so it's a Gaussian sequence. That's for continuum. But continuum is complete. To that time, I don't know right now, but to that time, complete. So the reason I choose Hindenburg model is because I can use discrete. So discrete is easy. So before I make a decision to use this one, I ask my advisor, say, okay, I'm thinking about this is my research direction. And my advisor say, I don't know, because I'm not a speech recognition guy. But as a CMU Palikimana, the famous one 是李开复那时候在那边李开复就那个时候，所以李开复他们有个 there's a very good speech recognition group. So my advisor tell me, in Palikimana School of Computer Science, we have a big speech recognition group. They are very good. You can ask student or professor there. But because in United States, the people are more open compared with here. 我还是承认嘛， 国外在做研究还是比我们台湾 open，因为你可以跟任何一个老师，所以我们常常都是共同指导，共同指导这样子。像我博士有3个共同指导老师。So I went to the speech recognition group. I asked and somebody tell me there's a PhD student. He's good at this one. So I visit him and he teach me. He spent half day teaching me what's the kingdom of Roma. And after he teach me, he told me, okay, and he give me his source code. Well, he can save my PhD career for at least 1 year. 他就把他做的那个全部给我。他做什么？他那时候做研究做什么？我现在还记得，因为他最后到 University of Florida 当老师，一个壮胖胖的高高的，他都是把 source code 给他做什么？他是做那个，因为 Carnegie Mellon 那时候是做那个无人驾驶在做的。那1995年是全世界第一个无人驾驶从美国东岸无人驾驶花7天时间开到西岸。那山里面很多人都在做，他现在做什么？就是说，当你有酒驾的时候的开车轨迹，跟没有酒驾的时候的开车轨迹，那你们从摄影机去辨识，然后帮助那个警察局去辨识，哎，这个车子，因为所以我们落后美国大概，我们技术大概落后美国15到20年是这个意思。那时候就很多只摄影机，那你这个摄影机要连起来，你看到车子开的轨迹有点怪怪的，你看就可以把它抓出来，所以还是模拟。然后他那时候跟我说，就很多 advance 很多技术是 Q&A 的问题，就我也没办法去收集那么多资料，怎么办？只好做 simulation。所以记得在1993年我在那边的时候，我们有一个 group，所以 CMU 有另外 group 很有名是做 animation 的，我不知道现在怎样，就是 human computer interaction 里面有个 group 做 animation，他们都会做模拟。就现在我们在做 sim to real 那些东西，那很早他们就在做这些东西，所以那个博士生他也是在做 simulation，他给我看那个轨迹，所以那个参数怎么样，我真的不知道，真的不晓得。然后他最主要他把 source code 给跟我教完，又把 source code 给我，所以我说那种研究环境是这么 open 的，所以我学长帮我不认识的学长帮我，所以之后我们还是继续帮学弟妹，就是有这种传。好，那回到这边，就 suppose we have 1 point. Actually, not only 1 point. It's probably in my case I have 18 points at most, but suppose 1 point. Equal trajectory to each time. Right? So what you can do is each time the position for that point, you can input to a model. It's Hindenburg model. Right now, deep learning model, you have model like a black box. 你把这个 model 当成黑格是 black box. So input 1 point, output is a facial expression, happy, anger, sad. We have 6 facial expression. But at that time, I do the facial expression, not only 6, I do the coding, 44 expression, muscle motion. I output 44 by 6. 我那个边是4个吧，有这个大概这样子。我们把它当成是6个一般的表情，好，就快乐、伤心啊、stress 那些东西，6个表情。好，那是一个点 ，1 point，right？1 point x y in input and output. We have 6 facial expression, 6 classes for facial using the model. How about I have 18 points here, right? 是这个video的。大概是这个，是 facial expression。 我们那时候就要做 meeting，是我那时候自己编的，自己编。这个界面我自己做的，用 Unix 做的。Workstation 那时候是没有，台湾是 PC 王国，美国不是 PC 王国。我去美国的时候，我那时候用 PC，去美国怎么没有 PC？1993年去，1991年我去美国，那时候是 PC 嘛，做代工做 PC。然后我去华盛顿大学的硕士，然后我就问同学说：“哎，那个就我们的 lab 那个什么学校这边有 PC， don't have a PC， don't have to have a machine. What is Mac? The other workstation, don't have a PC。所以 Mac 不叫 PC， Mac 啊，Mac 非常漂亮，很好用，所以 PC 是靠不 Mac 的，所以我那时候就开始用 Mac， 然后用 workstation。那这是点，我讲的是 visual points。As I remember is that 1, 2, 3, 1, 2, 3, 4, 5, 6, 7，七个钮，七个 1, 2, 3, 4, 5, 6, 7, 8, 7 points. So if I show you actually I not only input 7 points, I input each points, the entire points, visual space。应该是做辨识来的时间的，一起来一起。这样，对，这样。So suppose I have 7 points input to the black box, making them a command. Output is 6 facial expression. So what can I do? So original is 2 points, right? Input, and it got a 6 facial expression. But right now, I have 7 points. So the dimension is a 14 dimension for one vector. The 7 points, each point is x, y. So I have a 14 dimension vector for input, output. But for the Hindenburg, discrete Hindenburg model, they say this way. Any vector sequence, but for your large language model, the same. Large language model, your input vector probably is a 77, 80, or 100 dimensions. Your language or your facial, your image, suppose 100 by 100. So that's a 10,000 dimension for one vector. One image, 10,000 dimension. Or for language, it's longer. So that's your input vector, it's long, very long input vector. Okay. And you input to your model, no matter deep learning or Hindenburg model. So what can you do? So here, let's say, no, don't do this that way. Here is a desk those, go back to our example. We have, for one vector, we have 14 dimension. So in the space, 1 point is in the 14 dimension space. So I collect a lot of data before the facial expression. I collect probably 100,000 data. That's many points. And I put all the points together and I do the vector quantization here and create the code book. So suppose this code book size is 32. Sorry, yeah, 32 because power of 2, 32 clusters. That's meaning for each group, each cluster. Okay, I have total has 32 clusters. That's meaning I do the code is from 0, 1, 2, 3 until 31 code. 这样懂吗？我把所有的 sample facial expression sample 放在这个大投影到这个大的 space，就是 14维的 space， 然后去做 VQ 嘛。I teach you to do the vector compilation. Become 32 classes. That's meaning each sample belong to one D code. Okay, so that's meaning in my mouse, if I do the smile, okay, smile, and original is suppose I have a total of 10 frames for facial expression of smile, and a vector, suppose vector 10 vectors for one sequence. And based on the core book, based on the vector compilation. So this is a sequence for 17 dimension for each f. Become 1/4 number. So probably my expression will become 0.00077, oh sorry, 0.0055577. So that's mean my expression like this way. My like this one, my expression like this way. Okay. So if I call in the top is higher, so my expression becomes 0.057. That means smile. If I do discuss or go down, move down probably is suppose it's a 0.2333. I mean go down. So that's meaning original each high dimension can become we call symbol sequence. Each symbol is only one number. 就意思是说，在你输入这个在输入你输你的 deep learning 要输入你的 macro model 之前，你要先创造 core book， 高维度的东西对应到只有一个值的那个 code 一个码，所以你本来是一个微笑变成10个 frame。每个 frame 是14个 dimension， 现在变成每个 frame 变成一个码。那你就总共10个 frame 就10个码连续，又刚讲000。好，我们讲另外一个例子比较好，就我再重讲。假设我们正的用偶数好了 ，positive is a even, negative is a odd number. Okay, so my expression suppose is positive, smile. Your code will be 000, probably 444668888. It's positive. Negative suppose the odd, so by 00 and 113377, something like that. So that's a sequence. Okay, so you have a low sequence, and then you can recognize. So based on those sequence, we call symbol sequence. We input to our model, we can classify 6 kind of general facial expression， 就变成6种表情。概念是这样子。So similar to large language model, similar to the vision language model, they'll create core book to reduce your high dimension vector become core， 这样子，概念是这样子。Now, so right now our input to your deep learning or to your Hindenburg macro model is a symbol sequence for each facial expression. So this one is the same as activity of skeleton， 那个你骨架在做移动的时候也是类似这种东西。So vector compilation is powerful. Inside vector compilation, you need to create a core book. And based on core book, you can do the symbol sequence. So we back to the discrete time Hindenburg model. So here, okay, this lecture I would like to teach you is a finite state machine. I will teach you the concept of Markov model. And also, actually several important ones. What's the dynamic programming? when you read the paper, they say, okay, I use dynamic programming to optimize the best path. So dynamic programming equal to shortest path equal to optimal state sequence. Dynamic programming is a concept, is an algorithm, but this algorithm is open. 这个名词啊 ，dynamic programming 是一个观念，这观念有不同的演算法，不是只有一种，是不同的演算法。那 dynamic programming 的目的是什么 ？This is the algorithm we call dynamic programming algorithm. What's the purpose for this algorithm? For the shortest path. 最短路径。So the same as you do the chess, 你是下围棋，不下那个西洋棋、下象棋、下围棋，你都要去找出一个最好的、最短的路径。For example, we are here, Tainan. We use a Google Map. We visit Kaohsiung. So a long time ago, at the Google Map, you have no choice. This is give you the highway. That's it. But right now, probably they'll ask you, do you want the shortest distance or do you want the shortest time? Because shortest distance doesn't mean shortest time. Because different time have different traffic situation. Okay, so you have different kind of condition. Or they'll ask you, do you want to go the highway and you pay the money, or it's pay free, so you don't need to go to the highway. So they'll ask you different kind of purpose. All different kind of so each kind of situation, they compare and they have their shortest path, 就最短路径这样子。So that's so the shortest path we use dynamic programming to optimize the result. Okay, so I teach you what's the shortest path. Okay. And maxima posterior, I will teach you that. You'll skip this one. And finally, the other important we say trajectory, because all the paths is one kind of trajectory. So when in Thailand to Kaohsiung, probably we have 10 paths, 10 paths, 10 trajectory. Okay, and based on the 10 trajectory, we want to find the shortest path, the distance, or the time. You can do a choice based on different constraints, based on dynamic programming, based on the trajectory. We'll get a result. The result is based on maxima posterior probability. So I'll teach you this one. Okay. And if right now, if we apply all the concept to the reinforced learning, so this one. So inside or behind the reinforced learning is a trajectory, this one. And behind trajectory, we try to optimize this one, dynamic programming. 其实我们最主要是把它弄成路径。那在路径里面，就是要找出 we try to find a maximal posterior value based on dynamic programming. So the same, the reinforced learning, and right now they have a number, all are based on trajectory, based on what? Based on finite state machine, based on macro model. And so when you study the paper, they'll tell you, or if you listen, Jason Huang, he talk about causal, talk about reason. What's that? That's history. Causal reasoning in history. History meaning what? Time sequence. 跟过去的历史 那历史跟什么有关？跟时间有关，所以这是一样东西的。好，那我们继续往下讲。So when you do the recognition, right? We have one image, the spatial domain. We do the recognition. But for the one image, when we do the recognition, probably the pre-processing is what? You need to normalize the lighting using Gaussian model. You need to, for each image, you need to find the mean value, find the standard deviation for that image. So each pixel subtract with the mean value divided by the standard deviation become the same Gaussian model. So the purpose is try to for the recognition. So let's pre-process. How about the time? Because when I do the facial expression, I do a smile. I take 10 frames. You do the smile. You take 15 frames. So everybody, the time frame, time sequence, the frame number are different. How can you recognize this one? That's a problem. So let's call, how can you align the time? When I take your photo, your image is so small, the other image is so big. And then how do you recognize that? Oh, you need to do the geometric normalization. Probably detect the inner corner of two eyes and then zoom into the same size of a face for face recognition. 你在做人脸辨识的时候，不是丢进去就要辨识。You do the face recognition. It's not you input small face, large face, and got a result. No. You do the face recognition, you need to do face detection first. You detect the face, and you detect the inner corner 2 points, and normalize to the same size. And then we do the face recognition. That's called spatial domain normalization or geometric normalization. You do any recognition, spatial domain recognition, you need to normalize the input size. So recognition, before recognition is detection. You need to do detection first and normalize the object size to be the same and then do recognition. 是这样子做。So the same as time sequence. But here, why at that time I use Hindenburg model is meaning actually, like I said, this image sequence has 10 frames, the other 15 frames. Suppose if I use a time delay neural network, I need to worry about to be aligned the time. But if I use Hindenburg model, you don't need to worry about that one. They'll automatically help you to deal with that kind of problems. So that's powerful for Hindenburg model. Okay. So at this page, I will teach you what's the Markov model. So what's Markov model? First of all, Markov model also called observable Markov model here. Markov model also called observable 可看到的 Markov model. But that's not good. That's inconvenience. So Hindenburg model is better than observable Markov model. I will explain this one later. So first of all, I teach you what's the Markov model. Markov model is meaning this is state, 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 state. So suppose I have n states. You can assume n equal to 5. So the number of states is decided by you. The same as the convolutional neural network. How many layers? According to your experience. 根据你的经验, you decide how many layers. Here the same. How many states? You decide by your experience. But usually like 5 states. So suppose we have 5 states. So state. So So n equal to 5. So for each state, we have what kind of probability? First one we call initial state probability. That's meaning this type. This meaning each state, the beginning probability. So suppose I have 5 states and 5 divided by 5. So each initial state probability can be 1 of 5, 1/5. So that's meaning equal. So when you reset, you play the game. You play the game, you reset. And then the initial start, or suppose we have a traffic light, 3 traffic lights, right? We have red, orange, and green. Some of the yellow, okay, red, yellow, and the green, 3, 1. And when you policeman reset it, so what's the initial state? So if the each one, the initial probability is only 1/3, something, that's meaning you randomly. Probably the beginning is from red or beginning from the green. So when you reset at the time 1, what's the starting light? That's we call this one IK probability. So it is the same. But if you say, okay, each time when you reset the button, you push it, I want to start from green light. That's meaning your initial state probability in green one is 1, red one, yellow one is 0. That's called initial state probability. So Markov model, no matter it's software or hardware, the same. Hardware guy can use Markov model. So that's the initial state probability decided by you. 你可以命令它是要从哪边开始。The second one, we only 3. Actually, in Hinton Markov model, Gaussian model has 2 parameters. One is the mean value, the other is the standard deviation. Only 2 values. Markov model or Hinton Markov model has 3 parameters. One for pi, and then A and B. That's it. Pi A B. So what's pi? Pi is I just mentioned. Just explain that one. It's the initial state probability. Okay. What's the state transition probability? State transition probability. Also we call AIJ is meaning A is the probability from state I to state J. That's meaning here. Suppose right now I'm at a state I. What's the probability I can move from I to J? Probability. Or from I to N. For example, I use the weather, this one, for example. I start from the observable Markov model. So we suppose we have 3 times, this is in at the page 9. Suppose I have 3 kind of temperature. One is rain, the other is cloudy, and then sunshine. 3 different kind of weathers, for example. And then that's meaning we have 3 states. Each state is one condition. So I have 3 states. So n equal to 3. So suppose this is suppose today is Monday. Right, so begin from Sunday. I say suppose today is Sunday. Begin from Sunday. That's called initial state probability. Okay, so begin from Sunday. Suppose Sunday today or Sunday is cloudy. So here, okay. And next day is the Monday. So what's the probability from cloudy to cloud here? Self from cloudy to cloudy, we have 1 probability. from cloud to sunshine. This one, we have probability 0.2. From cloudy to the rain, we have probability 0.2. From cloudy to cloudy, we have probability 0.8, sorry, 0.6. So those probability we call state transition probability. So state transition probability is from state I to state J. The same as Gaussian model. Gaussian model, you have mean value, you have a standard deviation, but you don't have a value, you just have a parameters. You have a values because you collect the data. Based on the data, based on the equation, you got a mean value. Okay, you got a standard deviation based on equation. The same as here. You just do the connection with three sets of parameters: initial state, state transition probability, observation probability, three sets. Actually, three sets of parameters. Based on your training data, you collect the data and train, you got a result. For example, suppose each week we have 7 days, right? From Monday until Saturday, 7 days. Suppose you collect, suppose this week, right? Today is Sunday, we have 1 week. But you collect the data, it's a 100 years data. And the unit is for each week, 100 years. And right now, suppose right now it's November, right? So from November, today, Sunday, to November, end of the Saturday. Suppose November 1st to November 7th. And how can we do those parameters? So based on the 100 years, each year is 42 weeks, but suppose November 1st to November 7th. So we have 100 November 1st to November 7th. Based on those data, you train the Hindenburg-Markov model, you got the result. 我意思是说，这个结果，这些参数是根据你之前100年的历史。那100年的历史，我讲说10月嘛，11月1号到11月7号的资料的天气这些参数，就根据这100个 data， 我们来 train 这个结果，就得到这些 data。这个参数这样子，可以哦。所以这参数跟那个Gaussian model 一样，是根据你的 data， 你把它 train 出来、认出来的。那我现在try to explain to you is what is the state transition probability? It's meaning from state I to state J. That's meaning if right now it's clouded, so from clouded to clouded, with probability of 0.6. From clouded to rain, sorry, to sunshine, this one, 0.2. From clouded to rain, we have 0.2. That's state transition probability. And finally, is the observation probability. What's observation probability? It's meaning this one. This one meaning at a state J, you can see the observer, the results. This one is the similar to reinforced learning. When you learn the reinforced learning, there are new observation state. What's observation state? It's the same as here. In a robot, the observation state, you take one photo. That's observation state at the time t. Here, at the time, suppose observation state is meaning what? Meaning at a state, this one. At a state J, what's your observation? That's meaning, suppose we have a state here, because each node is one state. we have state here. So this state 2, we have state 1, state 2, state 3, state 1, state 2, state 3. But state 2, the observation probability is only cloudy, has no rain, has no sunshine. So cloudy will be 1.0. That's meaning this is observation. This one is observation Markov model. I will tell you what's the hinder. This observation, this one. So for the observation Markov model, each state has only one observation state. At observation Markov model, each state exists only one observation situation. So state 2, observation cloudy. State 3, observation sunshine. State 1 is rain. But what's hinder? Hindrance doesn't mean in this one. Hinder meaning each state. Suppose I have a 3 observation situation. Each state can exist 3 situations. So that's meaning state 2, the cloudy probably will 0.8. Rain will be 0.1. Sunshine will be 0.1. So total sum together will be 1.0. That's meaning in Hindenburg model is meaning each state exists all kind of observation situation. Okay, it's different. So this is more flexible. Hinden is more flexible. So suppose here is in Tainan, it's Kaohsiung, it's Taipei. So at some day, Tainan, the probability cloudy is higher, rain is smaller, sunshine is smaller. In Taipei, difference, but in Taipei, rain is higher, cloudy is smaller. Okay, and then sunshine is smaller, something like that. 所以说，就是说这里很重要一点是说，在我的 observation 它每个状况就每个 state 只有一种可以看到的状况，就限制住了，没有弹性。所以 Hinden 比较有弹性 ，Hinden 就是每个 state 它就把所有的可能状况都给你存在，只是说它更有几率高跟几率低这样子。Okay, so that's meaning observation symbol is meaning for state J, you can see the observation situation. So okay, that example, the observation situation condition is a rain, cloud, sunshine, 三种假设。So that's a definition for Hindenburg model and observation model. So back to traffic light. Actually, traffic light is an observation model. Why? Because traffic light with 3 states. Each state only has one condition. So traffic light is an observation Markov model. It's simple. That's simple. Okay, but suppose I do facial expression recognition. I have 6 classes. If you use observation Markov model, you need to have 6 states. Oh, that's fine. But if you use language you have suppose you have A, B, C, D, you have 26 characters. You only have 26 states. It's more complicated. So observation is not good for complicated case. But Hindenburg model, I only use probably 5 states to represent A, B, C, D, E, F, G, something like that. It's meaning each state have 26 characters. Some are higher, some are lower, something like that. Okay, so like Apple, APPLE, spell that one. So I can do, okay, A is probably in state 1. Then P is state 1, P is state 1, L is state 2, so something like that. So it can come only 5 states. I can represent all the characters, all the spelling. So in the Markov model is better. It's convenience. Okay. And then what's the matrix? So this one is matrix. So back to here. So in the Markov model has 3 sets of parameters, standard sets. For the initial state probability is here. So suppose I have 5 states. So pi 1, pi 2, pi 3 until pi 5. 5 states. The initial state probability. That's what I say is initial. Initial is meaning it's at the time equal to 1. Beginning. Your beginning state is which one is your beginning state? That's called initial state probability. The second one here, for state transition probability, is here. So that's meaning from state I to state J. So in this one, in this matrix, this vertical one, this I, horizontal one is J. So from state 1 to state 1, that's what's the probability. From state 1 to state 2, it's A1, A1, 2. Okay? From state 1 to state n equal to 5, this one. So each state, they will connect to, each state will connect to the other states. And what's the probability? Okay. But here, if I disconnect, so suppose state 1, I don't want to connect with state 2. That's meaning in 1 to 2, this state transition probability, you need to assign 0. So 0 meaning disconnect. Okay, in the beginning, you assign a 0 for that state transition probability. Because 0 times 0 times any value is 0. So that's the meaning disconnect. So this is the other important ones we call graph, G-R-A-P-H, graph. So when you do deep learning or transformer, some paper tell you this is a graph model. 这是一个 graph 的 model。那 graph model 代表什么？就是代表它有这些参数，一样。So if I do the skeleton, or I do the skeleton activation, 我就做这种活动。So suppose this point, the joint point, this is a state, suppose 10. That's state 11. So state 10 only connect with state 11. Suppose this is 9, 9, 10, 11. So state 11 will not connect with 9. So disconnect that one. It's called graph. So this is powerful. It's powerful, and the result is good, but complicated. So when you start a deep learning or transformer, people talk about graph, you'll feel headache because it's complicated. Because it is one. But it's good. It's powerful. Why? Because, for example, I said, suppose this state here, it's 1 point here, this state 3, and state 9, 10, 11. When you this point, you move here. These 2 points close. So if you don't use graph, sometimes you do skeleton, it will connect both points together. 3 will connect to 11. It will have a period. But because in your initial, your definition, no, 11 only connects 10. So at that time, that situation, it won't be graph. But if you don't use graph, you just use regular convolution neural network they will connect together。就是你在做这种属于不用 graph 来做的话，就不用 this we call state machine。If you don't use state machine, you will cause a lot of error, a lot of problems. But if you use state machine, they will reduce a lot of problems. Okay, so that's a concept. I will continue to talk about this one next hour. We take a break. 这个有点比较复杂，但是很重要的东西。